afternoon. My name's Richard Vaughn with Bosch Rexroth. I'm a senior automation engineer and wanted to give you a overview on EasyHandling, Mechatronic and Robotic solutions. A little bit of an agenda, just the three topics that you've probably seen on the agenda already is right sizing your Mechatronic solution, how to save engineering time and cost without sacrificing some quality, and then three levels in the selection process of a Cartesian or a gantry solution that are very valuable. So the first part of it, some of it's obvious stuff, but way overlooked in the industry sometimes that we encourage customers to get to us right off the bat is in right sizing a Mechatronic solution. We know the market trend is doing more with less. So the opportunity at hand is combining products from different technologies so we don't look like the guy in the picture there, which I tend to do occasionally. And then in order to have the right Mechatronic and Robotic solution, there's got to be a start line for the right sizing, which leads us to the key points. And the first point usually is the payload. How much load or weight are we moving around, you know? What's it going to mount to? Do we take that weight into consideration as well? And then the next part is the orientation. Whatever you're picking and moving around, do you need a gantry solution? Do you need a Cartesian solution? What type robotic solution are you looking for? And where can it mount? Is it on its side, on top of its head? Whatever the case may be in order to mount it. And then speed is another thing. The speed and acceleration or a timing chart for the application, very, very critical to have. And then on either of a gantry or Cartesian, you need to know the travel that's in there. So you want to properly size it for the travel and not be like the picture and hit a 9-iron where you need to hit a pitching wedge if you're a golfer. So. Positioning, accuracy or repeatability, very important where you know what's required here. So positioning, you know, if you're in need of say 0.1 millimeters of repeatability, you know, a ball screw is going to be the way to go. If you need 0.1, you can achieve that with a belt drive. So you can dice that down in the very beginning if you know the accuracy that's needed. Environment, very critical. So if you're operating in an environment like the picture shows, it's got a bunch of metal chips, or you know, if it's in a clean room or a medical environment or whatnot, very pertinent information to know up front in the operating environment and the selection of the linear modules that might be used in an application. Then another part of right sizing ends up being the duty cycle. You know, it makes a big difference on the lifetime of the components if you're selecting something that's going to run, say, 1 day a week, 2 hours a day, as opposed to 24 hours a day, 7 days a week, 365 days a year. So very important to take that into consideration. Then other parts, you know, do you need point-to-point motion, coordinated motion, circular interpolation, what type motion? So the proper control is selected for the application. Then you need to know the input voltage that you're going to be supplying to this system to be able to make it move back and forth. And then if you've got pneumatics on there, what kind of supply, what air pressure do you have out at the robot. One of the things from our company, from Rexroth, that we actually call the 4EE energy efficiency formula to right size. We have efficient components that are energy recovery, energy on demand, and energy system design. And basically taking those all into consideration, it actually allows you to properly max. You have proper components that are pre-matched together based on the sizing of the application up front, so they're the most efficient solution. One other thing to take into consideration when sizing is safety. You know, what type of environment is it going in from a safety perspective? We have some drives, our drive amplifiers for our motors. We can get safety on board. If you're not familiar with that, with safety on board, you can actually achieve Class 3 or Category 3 robotic safety by doing so. So you can save operators or whatnot with safety interlocks on the doors. And the way that works is with a dual processor on the drive amplifier itself to be able to do it. The next step after you properly have your system sized, one of the things, how to save engineering time and cost without sacrificing quality. We all want to avoid the finger pointing that goes on in applications, with less design work, less paperwork. And with that, we save on the logistics, integration, and design, which ultimately allows us all to save in cost, which is a great thing. And some of the ways that we achieve that from our side, we actually have some size and selection tools online that actually simplifies the engineering process for multi-axis systems as well as single-axis systems that we're working with. You have standard drive electric configurations that can be selected right from the sizing software. And then at the end of it, when you go through the process, basically what you do, you enter all the right sizing information that I explained earlier, and then it outputs a suggested solution and gives you all the way up to an assembly plan, so you can put it together. So that's a nice feature. And also, there's a CAD configurator that comes with it, and that's something that's really critical in saving engineering time and cost, is being able to spit out an assembled drawing any time that you can save it. Our CAD configurator goes ahead and it puts together with the bill of material the components and gives you different formats such as a step drawing or DXF or whatnot that's selectable for whatever software you're using to view them. So some pretty nice features to help save on some time. One of the biggest things that I encourage after doing this for about 20 years is the fact that catalog components, the more catalog you can say, the better off you are long term. And over the years, we've evolved, and we have a program that allows us to utilize even more and more catalog components in the selection process to eliminate non-standard design, as I would call it. And I kind of give a little example right here of catalog versus non-standard design. Your potential cost savings, it's not always obvious up front if you're just looking at the numbers, the dollar figures, and what it's going to cost apples to apples. And sometimes you have to look at, you're going to save on the mechanical, pneumatic, electrical, and software design, as well as having pre-matched components. The assembly is a whole lot easier, so you're saving on assembly time, commissioning, and startup. So it gives you a cost savings that might not be realized on the dollars up front in purchasing the components, but over the course of the project is a definite cost savings. EasyHandling is a system that we offer at Bosch Rexroth that gives 3 steps in selecting a Cartesian or a gantry solution. You can see the different facets that it has here, and it goes from the mechanics to the pneumatics to the control systems to the drive systems, and it brings them all into that same package where I was talking about that our sizing tool does online. What we have, the 3 different levels, is actually a basic level, a comfort level, and an advanced level. So with a basic level, what you get is your mechanical and pneumatic components all the way up to the motors and drives. So you can either get it as a kit or you can get it assembled, and it's just a basic configuration that you can get even with cable management on it that would be up to a motor. Right there would be the stopping point for a basic. Once you go to the comfort solution, what the comfort solution does is it adds our drive amplifier in there, and the word pre-parameterized on the slide there in the commissioning assistant. We have a easy to use software that allows you to go through 6 easy steps in commissioning the drive amplifiers now. It's a great thing for me to see, is it's very needed and match our linear products with our motors and drives. And what it does, in essence, there's a data plate on the linear modules that has specific to the part number, as well as the information's on the module itself. It actually has the max torque, max speed, acceleration, and any other pertinent parameters like the ball screw pitch and everything that you'd be thumbing through a catalog to get. It's all in there. So when you're going through the commissioning assistant, you can just go through the step-by-step process, and when you get to the screen, enter that part number in. It pre-populates all those parameters for you. So it eliminates the need for thumbing through a catalog and putting it all out, so that it's less room for error in entering that stuff. So I've found it to be very useful myself, and what I've played around with it. And then we take it to what I call an advanced, EasyHandling advanced solution. And what that does, that takes the comfort and the basic and kicks it up one more notch, and it adds a control to the solution. So you have a pre-configured scalable control, and we have a software called Intermotion for handling that runs with a robot mnemonic code. Those of you that are familiar with robot programming, it's simple point-to-point, and you can teach your points with a teach pendant. We've got an example in our booth right now that any of the guys will be more than happy to walk you through if you'd like to look at it a little closer. So if your vision's basically a mechatronic solution and you're looking for a turnkey motion solution with compact parts that's either high precision or low precision, and you want it to come together, our positive locking interfaces is a critical key to the assembly process. Those of you that have used dowel pins through the years or whatnot, we actually have some locating ring holes that are machined onto the module components, as well as all of our products through our pneumatic product line, linear module product line, that connect them all together through the bracketry. And these locating rings allows you to, just pop together an XY or an XZ system, and it's using standard brackets for all the module combinations that are on there to do these configurations. So it's once again an off-the-shelf component that you can do multiple ideas and configurations with. The commissioning assistant I mentioned a minute ago, one of the features in the Intermotion for handling software that we have is a maintenance feature now it's tracking the mileage basically, and you can program it if you know you're running this thing 24 hours, 7 days a week, and you want to force an end user, an OEM or whatever to lubricate it or be reminded to lubricate it, whether it really happens or not. You can set screens up just by entering, here's the lube interval I want to set it on when it gets to this mileage, or the mileage that we would recommend when we size the application for you, and it'll shoot up a reminder that you'll be able to lubricate the system at that point. And then you can customize all the different designs as well, which is a very nice feature in coming together. That EasyHandling solution, it's more than just a kit of components, it's a true solution at the end of the day, what you have. With it, we're easier, faster, and more economical. Easier by getting the result that you want, by going through the sizing software I showed you earlier a little bit, the Easy Select tool online. You've got the result that you want right off the bat, so you've got matched components right out of the catalog, less engineering. It's fast assembly based on the positive lock-in interconnection with our centering ring technology. It's a faster route to optimal applications because the commissioning wizard is, like I say, I can't tell you the value in savings just in going from start to finish and parameterizing a 3-axis Cartesian system. It's a lot less time, than thumbing through catalogs. So it's more economical, saves you money. It's efficient because of the runtime, travel-based calculations that you have in the Intermotion for handling software. And it's an open system architecture. It's not limited. The PLC itself is IEC 61131-3 certified and is compatible with all those where you can program in ladder logic or whatnot, structured text if you're familiar with it. So you can even take our standard solution and say, hey, it's 80% of an application, and then if you've got weird timers or whatever you need to add on the PLC, and we've got the ability to do that. And the basic, some of the stuff that we've got there, we've got both the mechanical and pneumatic components, grippers, rotary modules, motors, sensors, and as I mentioned earlier, single and multi-axis systems that can be delivered either as a kit, as individual components, or as an assembled solution if you want it to come in boxed and assembled completely. This is some examples. It's by no means a limitation of what we can do with our product line, but it's examples of a pick and place application. The one shown is a pneumatic pick and place. There's a linear gantry application that's shown there. You've got a Cartesian system with a cantilevered arm that's shown in the bottom left-hand corner. You've got a Cartesian system gantry that's there. So just some ideas of applications that you can do. There's many, many more, and if you have any applications, we'll be glad to talk to you about them. Just an idea of some of the pneumatic components that we have at the basic level. We've got some rotary modules that allow high torque, minimum space, precision. You've got sensor grooves on both sides of the actuator with intelligent stroke adjustments. You can either have hydraulic or cushioning on the adjustments to adjust the stops that you've got internally in it, fine-tune it. We've got our GSP gripper series that you can get either an angular, a 90-degree, or a parallel gripper that has high drive power, compact design. It's for handling system applications. We've got feed modules. We've got one running on a demo that we've got in the booth right now. It's high precision, combined high force and high torque rating. It's a good, what I call, addition to a Cartesian to get motion similar to a Scalable robot because it's feeding just the thrust rod itself, and you don't have to worry about the weight of the whole module. So it's intended for more lighter weight applications, high-speed, lightweight type stuff. MSC pneumatic mini slide. You have high drive power, compact design. It's for handling systems, and it also has an intelligent stroke adjustment feature that's on there. Our compact modules, probably our highest selling, biggest selling module series, our compact modules and our linear modules that you see at the bottom. We offer those both in belt drives and ball screw drives, so whichever you would need for those. The difference, the compact module has a dual ball rail system integrated in it, so it gives you high rigidity and a high load rating because of the two ball rails that are in there. You get high traversing speed and precision with it. The linear module, it's only got one ball rail in it, but it's ideal for applications where you have like a three-dimensional gantry and you're limited by space and you want to run two x-axes with a single ball rail running in parallel. It's a good solution for it. Some examples of the motors that we offer, some of our smaller motors, the MSM motors, they have high power density, short length, servo motor from 0.48 Newton meters to 7.1 Newton meters. We have absolute encoders that are utilized on the motors themselves. Our MSK servo motors cover a larger end of the spectrum range. You've got 1.8 to 24 Newton meters. Same thing, we use absolute encoder systems, but also different encoders are selectable based on the pulse count that you need for higher precision. We could go into more detail with that. We do have some linear motors, the MCL that's at the bottom of the screen there. High accelerations up to 300 meters per second squared, speeds up to 1,200 meters per minute, and a force up to 1,700 newtons. Some pretty stout stuff to move around with the linear motor. One of my favorite things, call me crazy, but the cable management to go with it. As a engineer by trade, it's always one of the last things that end up going on a job. So having this stuff in a catalog that's pre-selectable and being able to put it on there, it's good for me because I know how many jobs I've had personally at the last minute throwing the stuff on and having to come up with custom designs. So the standardization on the bracketry is invaluable at that point. We have ESD, electrostatic versions of it, different number of cross members. They vary with the size. Some of the other stuff that you see on there, we've got sensors that you can mount directly to our linear slides with the bracketry shown there, either Hall effect sensors or reed sensors. And the connector kits that I briefly touched on, that's just a picture of them right there. But you've got our clamping fixtures. They interlock to the positive connecting system that's already integrated and machined into it. So with the comfort, where I mentioned you get the pre-parameterized servo drives and the commissioning wizard, this would be an example of an architecture that you might have. So if you wanted to use a third-party control and interface to our drives via multi-Ethernet or what your interface is, Profibus or whatnot, this is an example of a configuration and how the field bus would connect to it. From the comfort level, we've got a software called Endersize that's available online and downloadable that you can size the motor and drive combination. You can even do it yourself, but we obviously work with you on those applications when you have them. Takes into account the mass inertia, and once again, it's so important to stress it avoids over-dimensioning. It's right sizing that we touched on earlier. So very, very critical in doing that. The Ender CS, the drive that we offer, it's available from 100 watts all the way up to 9 kilowatts. So there's a wide range of power available in an extremely compact design that we have on it. The multi-encoder interface, you can do third-party encoders or whatnot if you need to integrate a scale into it. You've got the capability to do that. The safety on board is compliant to IEC 61508. That's how we're achieving the Class 3 robot safety when we get there with it or have a need to it. And once again, the PLC is IEC 131-3 compliant. This is an example of 6 easy steps. I'm not going to bore you to death with that part. If anybody wants to go through the steps that we've got, this is just an example. I know you can't see all the details on the slide, but we have a kiosk set up in our booth that we can walk you through step by step, going through the Easy Wizard that allows you to use the master communication, then go to the basic communication, enter the mechanical data, then operation mode, set absolute position and the position limits, and then in 6 steps in about 10 minutes, you're up and running, you're ready to jog. So for me, from my programming background, if you've got motion, you're ready to go. It's all a piece of cake from there. So on the advanced part of it, with the pre-configured drives and controls, this is what the architecture would look like. Using our Ender control, our L25, 45, or 65 PLC, you have a couple of options of HMIs. We've got a whole kiosk full of different HMIs that are available. You can use our Ender Motion for Handling solution and connect directly via Circos 3, which is our bus of preference, to the drives that we utilize. And if you've got peripheral that utilizes a different bus, you can tack on a Profibus card and communicate to different peripherals at that standpoint. Anything that's pertinent on this, the Ender Motion for Handling solution, one key point with it, it's intended for point-to-point motion. It does what's called path optimized. You can start one axis and another axis at the same time from the same point. And if they have different travels, they're going to arrive at point B at the same time. So it's optimizing the path to get there. If you have a need for a true circular interpolated axis, it's not the right solution for it. For a glue-in or tracing that requires true circular interpolation, we have controls that are capable of that, but this would not be the right solution. So with that, you've got a prepared set of drive parameters that help speed up the commissioning of the control itself as well. It's open source code, which, as I mentioned earlier, if you have add-ons that you need to make as an end user or whatnot, you can modify the code and do some crazy things with it using the motion that's already there. We also have drive-based solutions. With that, we've taken the PLC and we put it on the drive. You're limited with the I/O and the processing capability, but you can do simple point-to-point moves. You don't need a lot of I/O. It's a good, more economical solution with the drive-based automation. Everything's merged onto the PLC, and it's the same thing, simple connectivity, the architecture and the structure. This is our L25 and our L45 control that was shown in the other picture. It's cost-optimized, embedded hardware architecture that's available in lower and middle power ranges. You can see the connectivity that we have on there, Circos 3 and multi-Ethernet being the key ones, and then plug and play with Profibus and interface extensions, as well as flexible periphery through the Scalable I/O portfolio that we offer. This is just an example of one of the HMIs that we've got. VCP, this one would mount on a machine panel. We also offer them as handheld teach pendants, so you've got different options that you can go with there. This is an example slide that actually shows where I was telling you is tracking the mileage that gives you the recording, alignment, and the visualization of maintenance hints that you can put in there and say, hey, I need to lube this every 60 days, or I want to lube it when it gets to a certain mileage, to pop a reminder up to you. So basically, it's a fast overview that I was able to give you that goes through the basic, comfort, and advanced levels, combining our linear modules, motor flanges, up to the servo motors, drives, and the interfaces. So the applications that you would typically see them in: general factory automation, assembly, dispensing, handling, joining, measuring, solar cell production, electronics and semiconductor, and medical, pharmaceutical, pretty much any type handling applications across the board. We've got these systems running in. So but the way to get easier, faster, and more economical, you can see starting with the engineering process through assembly, commissioning, production, over to continuing development if you need to add on to the systems, results in the EasyHandling. So basically, that's all I've got for you. We're located in booth number 1308. I appreciate your time and thank you for your attention. If anybody's got any questions, I'll be up here for a while. I've got a few brochures if anybody wants one, and there's definitely more details if you want to come by the booth. I can hook you up with showing you any more detailed information that we've gone over here. So thank you so much for your time.